Hi and welcome to video 4, this series on sampling and confidence intervals, Unit 4, Topic 4, Mathematical Methods. And we're going to talk about sampling from a large population. So we usually sample because a population is too large. The end goal of this whole topic is about how do we use samples to predict population statistics. But for now we're working on some assumptions to do with the population. So imagine that we know the population proportion of parcel weight sent to Australia Post of being under 1 kilogram is 0.63. So 63% of parcels sent by Australia Post is under 1 kilogram. You notice here that with this example again we've made it binomial, which is important. So in this sample, basically your attribute is a question being asked to make it a yes-no thing. Is it under a kilogram or is it not? If instead we're just looking at a scale of how much it weighs, it changes the approach that we would take. So for now we've just got that success failure coming back in. Let's say we take 5 samples. So I want to know the sample distribution of the situation above. Using a table in your calculator is going to be our approach. So let's do that now. And I've got some information here. We're going to build a table, and to do that we're going to do this thing here. So let's have a look. So I exit out of here. I've been in statistics from a couple of videos ago, and I go to item 7, table. Now I've got a load of stuff in here, and if you go to F2 you can actually delete all, and I don't need them all. So I'll try that again. I know I can just delete each one individually, but in some of the menus you can delete all. So I'm just going to go through and delete them all. So you should keep this clean, although you can keep quite a few of them, so it doesn't matter if you do keep quite a few of them. I believe my list runs out soon. There we go. Now I'll go up to Y1. And I'm going to put in the information that's provided here, the idea that's provided here, which is to go into option, and an option to go into stat, which is across, and F5, go into distribution, a binomial distribution, and I would like a BPD. So in my BPD, I want to collect first of all X, and I want that X, so that's going to represent my value in the table. And I want that to have a be chosen as part of a sample of 5, and I would like my probability of success to be 0.63. I'll close that bracket and just press execute. But now I also need to just go to this set menu, F5, and just make sure my table is set appropriately. So I want to have a lower bound of x equals 0, I want an upper bound of x equals 5. And my steps, I can't have decimal steps because it's discrete data, so I'm going to go up in ones. And that will be my table. So now I'll press F6 table, and it will give me my value. So of course, with a probability of 63%, the chance of me getting 0 is quite low. So I get that 0.00069. Sorry, 0.0069. But then I move up to 0.059. So if I move my OneNote to the side here, I can fill in these numbers. So I get 0.0069, and then I get 0.059, 0.201, 0.3423. It's been a little bit inconsistent in rounding, but then we get 0.2914 and 0.0992. And there's my probability distribution straight from that table there using this notation. It's a really important way to understand how to do it because it might come in handy. What are the values for the expected value of x, and of course the standard deviation of x? So again, we can just go through the simple methods from last time. We did a bit of proof, but simple methods now. And the simple methods are the expected value of x is equal to NP, which is equal to 5 times 0.63, which of course is 3.15. That's my expected value. It's obviously decimal, but it's saying that probably the most likely outcome is 3, maybe 4 is the next most likely outcome, and that sort of comes in there. You can see it folding in with that idea. 2 is pretty close as well. The standard deviation of x, I'll skip variance, but the standard deviation is the square root of variance, which means that it's equal to the square root of NPQ, and that's the square root of 5 times 0.63 times 0.37. And this is something I'll have to calculate. And that is 1.08. So I've got a standard deviation of 1.08. So there we go. All the best.